Hey folks, today I want to introduce you to a powerful little database that's going to appeal to anyone who crunches numbers. It's called DuckDB. DuckDB is an analytical database. It's designed for running complex column-oriented queries on large data sets. It can be used to quickly ingest data from sources like CSVs or JSON files or Apache Parquet and run queries on that data using familiar SQL syntax. Wrappers for DuckDB are available for all major programming languages, and you can use it directly from the command line. Plus, DuckDB is all contained in a single executable, so there's almost no setup process. You can add it to a Python workflow, for instance, by just installing the DuckDB package in Python. So to get an idea of how things work in DuckDB, let's take a look at some simple data ingestion and filtering using Python to run DuckDB. Now I have here a couple of data sources, both arbitrarily generated for testing. One of them is a 4.6 megabyte JSON file, and the other is a 341 megabyte CSV file. I want to run some queries on these data sets using SQL syntax, and with DuckDB I can do that directly on the data in memory, or I can convert the data to a DuckDB native database and work on it persistently. Let's start with a JSON data set, and let's set it up for persistent work. To set up a new empty DuckDB database, I can use a context manager in Python like this. This will either create a new DB with this name or it will open an existing one. I could then use an SQL command to create a new table, names, and populate it with the data that's read in and converted from our JSON file. We can then see the columns automatically detected and generated from that data, and we can also see the row count. And next, we're going to run some queries against this data. We're going to be using a dialect of SQL that should be pretty close to the standard SQL we all know. We can then print those results to the console, or we could do further work with the results as Python objects. So at this point, I should also note that the DuckDB language libraries let us do many of these things in an object-oriented form. So it's a little bit like having a built-in ORM. But for the simplicity and directness of this demo, I'm just going to use SQL queries. So let's run this sample and see the results. The first timing that we have here is the time that it takes to ingest all 4.6 megs of JSON and turn it into a database. And then we have the columns that have been generated, and then we have our query results. The queries themselves run very quickly, as you can see. And when we print the query result objects to the console, they automatically come out in this nice, pretty printed format. For comparison, let's do the same things without creating a DuckDB file. Let's do it all in memory. This script opens the JSON file directly and reads it into an object, basically a single data table, from which we can also get a list of columns and the row count and run the same SQL queries against it. The syntax is just a little different. So when we run this, we're getting the same results, but look at the timings. The time to ingest the data and set it up in memory is much faster than the time to set up a persistent DuckDB file. But the querying time is much slower. So the convenience of ingesting the data directly and not having to create a file on disk is offset by the queries taking a little bit longer. You get to pick which approach you want. The same goes for this other example. This one loads data from a CSV file, and it's that monster CSV I was talking about earlier, 341 megs. And in my first example for it, I load in the same database file under a different table name, and I perform a query on this data. So if we run this, you will see the process of ingesting the file and adding it to our on-disk database is quite long. The actual querying is quite snappy. In this other version of the script, we're loading the CSV directly into memory, and we're using it there. And with that version, we get a much faster read-in time because we don't have to write everything back to disk, but the querying itself is somewhat slower. It's not drastically so, but it is noticeable. Another big feature with DuckDB are the analytics functions that are built directly into it. Let's say I have some query that I want to perform, but I don't want to use the entire data set I have to do it. I just want to use a sampled subset, and DuckDB has a native mechanism to that end. So here we have a query that's going to be run against our imported CSV of name information, and it obtains the minimum and maximum values in a date column. The first run does this for the entire table of 300 plus megabytes. The second for a 1% subset sample of that table. The second run executes, on the average, much faster, and it produces an only minimally different range of dates. So this gives you an idea of how much precision you could trade off for working with that much less data. and what the sacrifices would amount to in the long run for the work you're doing. So there's many more mechanisms like this built into DuckDB, and while they require some getting to know, whether through DuckDB's specific SQL syntax or through the language libraries, they make these kinds of bulk data analytics operations much faster and more streamlined. And they can be set up and run with far less overhead and far less boilerplate and rigmarole than many other analytics database solutions. So that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.